It's the Pi1541-III, a solution for loading software on your C64. What makes it different? Well, it's the third one I made, after number 2. Join me in the basement for another adventure, now with even more leaded solder. And we're back, so let's keep going back, all the way back to 2018. With Stephen White making the software that enables the Pi1541 to work. I could have made it on perfboard or something like that, but I wanted to make a proper shield out of it. It wasn't the most common alternative out there, but a few of you may even have seen it or purchased one of them at some point. 2 years later I had grown more confident in KiCAD, and so I made another one. Better looking, a case without actually being a case, and needlessly expensive. Relatively speaking, of course. In 2023 I had grown overconfident in KiCAD, and so I made another one, but messed up the 2 first revisions due to rookie mistakes. The added features is the rotary encoder and the larger 1.3-inch display. And in a nutshell, that was the tale of my 3 Pi1541s. With all that said, let's get to building one. In order to build one up, as shown, you're going to need 5 separate PCBs. The first of the PCBs is the main module. This will hold most of our components. Next step is the module panel, where we'll be installing user interface parts such as the display and rotary encoder. The remaining 3 are optional faceplates. While they serve different purposes in this design, they're mostly there to make it all look cool. Oh, and probably add some mechanical stability to the design, at least the one that goes on top. While all of the 5 will show up in different parts of the video, the 2 we are going to focus on are this one, the module, and the smaller panel below it. The first components to get soldered into place using my good 6040 leaded solder is a handful of resistors. Starting with these 10K ones, they're needed when installing a bare rotary encoder on the front, such as this one. You could probably get the higher quality ones that these are probably a cheaper copy of, but they didn't have those on AliExpress. While you could definitely do without one of these component lead shaping tools, on the other hand, they give me a feeling of being a proper engineer again. Cracking on, we'll just pop those 2 into their designated holes and bend the leads slightly outward. It'll annoy everyone who will try to desolder them in the future. But then again, if you need to reclaim individual resistors, then I suggest that you rifle through your sofa cushions looking for coins instead. The next 2 are 1K, so just give them the same treatment. We will, however, need to have an honest chat about those LEDs, the ones that are going to be installed onto the panel. They're roughly in size, equal to the ones found on the original 1541-II disk drives, except I could only find a yellow and a red one. The original had a yellow and a green one. For whichever colors caught your fancy, you need to pick a suitable loading resistors for them. And the color usually dictates what you use. If all of that sounded very difficult, then let me just Google that for you. All done with the maths assignment. ready to melt some metal and spin some tunes. Excellent. You need to install a good 14-pin socket here, simply because ordering 7406s have become a game of chance. Sometimes you get really good ones, cheap, and sometimes you will pay premium for counterfeit products. Seems most vendors don't even know which ones they have. Match up the indent in the sockets with the outline on the PCB and just solder it in place. If you're wondering why I'm not using the audio from the video itself, this is why. Enterprise was kinda awesome. For the small value capacitors, there's only one and there's no polarity, so just throw it in there. These level converters keep the Raspberry Pi from burning up when trying to talk to the now ancient C64. But for all the love of Commodore, seems like Acorn, in some form, won out in the end. Yet they still burn in direct competition with a Commodore. As will my membership on the Slashdot forums. These come in several different variants. The one I'm using is the 4th channel and usually comes in this blue PCB. Note that the red one usually has a different footprint and can't be used. So when in doubt, look for the blue one. They're cheap, but not exactly very well put together. For that reason I'm cutting some of these female pin headers to size so that I can plug it in and, well, replace it easily. When you're happy with it, just solder it to the board with a somewhat straight alignment. Solder some straight pin headers to the bottom of the module itself. The Pi header is just a 2x20 pin female header. It goes in straight, and actually that's a lot of pins to the solder if you mess it up now. To get some sort of sound when loading from disk, we can add a passive buzzer. When ordering, you may end up with an active one instead, something that's easily tested with a small battery. The correct passive buzzer will make a sort of ticking sound like this. The pads for soldering it onto the board may look a bit strange, but it's just there so that we can account for the more common sizes available. The single larger capacitor that we'll be adding is a polarized electrolytic capacitor. We need to match up this white stripe with the filled in white area on the footprints. The positive side of it will have a longer pin, such as shown here, but if you're using reclaimed parts, that may be missing. But we'll just throw that in real quick and be done with it. This project is using a standard barrel jack for power input, simply because I found it easier to obtain a reasonable quality power supply with the standard barrel jack plug on it than it is to find a Raspberry Pi specific power supply. It may be a bit harder to get it straight the first time, but I found that soldering a single point and then reheating it is easier to get the alignment correct afterwards than just solder in the remaining solder points. I found these listed as 6-pin S-terminal connectors on AliExpress. If you shop on more reputable sites, you may get one that has a more rounded shape on top instead of these boxy designs. They work just the same for this particular project. While it's nice to have two of them, but you strictly need only one. It doesn't matter which one you end up installing. Just ensure that they sit flush against the board before soldering in all of the pins. Looking at the panel real quick, this is how it'll slot into the module. The overall construction is held together by using M3 nylon hex standoffs. These will be of varying lengths depending on where they're used and how. These 6mm male-female standoffs go on the bottom of the board, while the ones added on top of the board will be 20mm long. That's a pair of them for each of the 4 corners. If you're not planning to install the bottom faceplate, then I suggest replacing the 6mm ones for 12mm instead. For the standoffs at the front, we need to ensure that they are aligned to sit flush with the outside edge. Here I'm just demonstrating this with the panel board. Remember to perform the same alignment on the bottom standoff as well. Check your alignments and you won't have your standoffs stuck in a Midwestern standoff. Let's get the module out of here and start looking at the panel itself. All straightforward on this side at least, but turn it over for some fun stuff. Solder jumpers. The jumpers in the middle need to be set according to the type of OLED that you're using. It's probably more accurate to say that it all comes down to the clone of the module that you're using and who made it. So with it out in the open, let's take a closer look. On the blue display at the bottom, we can see that the first pin isn't marked ground or GND, meaning that both of the jumpers need to be soldered across pins 2 and 3. The super tiny triangle shows you which is the first pin. Before finishing up the jumpers, we'll also be soldering the ones for the rotary encoder. Those go in the 1 to 2 position on both of them. I'm back. Hope you had a tranquil moment not listening to me. Next we're adding some right angle pin headers to the board. That's the back of the board. If you can't see the outline of the switches while you're soldering, then please stop and check yourself. The work, that is. You're probably fine. It's that time again. It's standoff o'clock. These are 8mm, and because I ran out of space, I shave a bit off two of the opposing corners on each of them. Don't need to take off much, just 0.1mm or so. Let's go nuts. By using them to fix each standoff to the four corners of the PCB. Standoffs in front, nut in the back. Standoffs must be aligned with the shaved off corners towards the bottom and top edge of the PCB. Nuts should sit flush against the closest edge. Let's add some 2x5x7mm rectangular LEDs, and to do that we're going to need some tape, a front faceplate, and even more standoffs. Each of the LEDs should have one leg that is longer than the other one. This longer leg goes into the hole with the round pad. Don't solder anything yet. For now, just add the faceplate on top. Fix it temporarily in place using some spare standoffs. Take a piece of tape and use it to cover up the holes for the LEDs. Gently push the LEDs into their final resting place. Flush with the surface of the faceplate. Solder, and let's continue. Back inside the panel again, we can admire the engineering that went into those LEDs. And what better way to do that than adding around 8,000 more of them. Plop it gently into place. Again, soldering absolutely nothing. Add the faceplate back to it again. This time ensuring that we use 4 equal sized standoffs to do that. The main thing is that we need to be able to put it down on a level surface without anything wobbling around. The lower edges of both the faceplate and OLED should have their lower edges positioned directly on top of each other. Simple way of doing that is to use a spare board as a guide. Carefully solder a single pin into place. Turn the board over to check that everything looks straight and that you're happy with the results. If not, then you may need to reheat the solder joint and try again. Looks good to me. So let's get back inside and add some switches. These are your standard garden variety 6x6mm momentary switches, except that we need some that have a height of at least 10.5mm or taller. If you're unsure about the height or that you get them in straight, then just add the faceplate again. But I'm not doing that again. With the switches soldered in off camera because they annoyed me, let's talk about a pack of rotary encoders arriving in a bag. Some of the pins were horribly mangled, but I got it in there anyway, soldering it in, and readjust the position by burning my finger in 3, 2, 1, now. Everything looks good, so let us properly and for the final time add the faceplate onto there by using proper actual screws. And with those going in, I think it's time for a short break by going enough of that. We only made the panel. So get on with it and let's skip the obvious joke about putting on the medium-sized black knob. This, however, is all about installing the panel, which, if we did all of the work on aligning all of the standoffs in the correct orientation, should allow us to simply slide it into place. The pin headers, however, may require some slight violence. As tempting as it may feel right now, don't solder anything yet. Because first we need to add the FB1 faceplate to the top of the device. It sandwiches the panel into place and we have a much stronger mechanical construction. Temporarily add some standoffs to each of the 4 corners, and soon we'll be ready to do some soldering again. So let's just do that. Installation of the Raspberry Pi 3 is also somewhat of an adventure, but first we need to get in there, so get the top faceplate out of the way. The Raspberry Pi will slot nicely into the design, but we need something to support its weight, so we need another standoff. There are no commonly available standoffs that will fit properly, so I am adding a nut to the bottom of the standoff and we get the desired height. We need 2 of those and attach it to the board with a nut on the underside. As we're already adding parts, let's just get the voltage level converter into place. Make sure to match the writing on it to the markings on the silk screen. I'm also adding the 7406 IC, making sure to match the little indent or dot on it with the indent on the socket itself. If you have the bottom faceplate as well, we can install that now. It covers up all of the solder points on the bottom so that we don't accidentally short circuit anything. The design is reversible, so you can pick whichever you like. Add 2 nuts to each of the corners, so 8 in total. But I digress. What we were going to do was install the Raspberry Pi into place. But we have the standoffs and everything. It's just a matter of plugging it into the header. Make sure that you don't offset anything, but at least with the Raspberry Pi 3 something will be in the way. Do note that you may have to trim some of the screws that's coming out of the panel backside, also the pins going to the rotary encoder. If you feel like something's in the way, then that's probably it. Add some screws to the top of it if you'd like, but really it's not going anywhere. Except if you drop it on the floor, but that can be said for vintage disk drives as well. The final touch is to get out the top faceplate again. If you can't find it, it's probably behind your desk, along with some screws. Recover said screws and put the faceplate into place. Hopefully this is the last we'll see of the inside of the device. Considering that the video is already dragging quite along, I'm skipping ahead a bit and use a preloaded SD card. If you need information on how to put that together, I'll probably do a second video for that. Anyway, with the good 5-volt power supply plugged into it, we can now use the device, and everything seems to be working okay, so it's time to look at connecting it to a Commodore. And in case you were wondering, here's what that would look like if it had been spray painted beige by someone who has practically never held a spray can before in his life. It won't win any design awards, but I'm happy with it, and that's all that matters. And so, that's the video. As mentioned, I'm going to have to do a separate part on setting it up. That should include the actual parts of preparing the SD card. Well, I'm sick of hearing myself talk, so bye.